morning, students. So where we were doing acidic character of oxo acids of halogens. What we are doing? Oxo acids of halogen. And in the oxo acids of halogen, we have to start with their acidic character. Okay, so when we are going to start with the acidic character, so number one is there, we are having HClO, HBRO, then HIU. Okay, like this way it is there. Then what is now the question arises, why HClO is having a highest acidic strength as compared to HBRO and HIU? Okay, then what to do there here in this case? You see, please, all of you. So whenever we are talking about the HClO, so HClO usually we are writing HOCl. Okay, let it be, I am writing one more, that is HOBr. The next one is here I am having HOI. Okay, student, now you see what is going to happening over there. Now from the Cl, Br and the iodine, which one is having more electronegativity? Cl is having a maximum electronegativity, then Br, then at the last iodine is here. Okay, so Cl, it means Cl is having a greater tendency to attract the electron from the oxygen, am I right? Cl will attract the electron with the greater tendency, Br is having a less tendency, and iodine is having a least tendency. Yes or no? And when the chlorine will attract the electron from the oxygen towards itself, then what will happen there? Yeah, then a release of H positive ion will be easier from the HOCl. Why it is so? Because when the pair is going towards Cl from here, then on the oxygen electron density will decrease, and due to that this OH bond becomes weak. Okay, but due to that OH bond becomes weak. Once again I am repeating you, from HOCl, HOBr and HOI, HOCl is having a maximum acidic strength. It is due to the reason that Cl is maximum electronegative, iodine is least electronegative. So Cl is having a maximum tendency to attract the electron towards itself from the oxygen. Okay, and due to that, when it will pull the electron from the oxygen, then O and H bond becomes weak, and the release of hydrogen becomes easy. Okay, the release of hydrogen will become easy. That is why HOCl is having a maximum acidic strength and HOI is having a least acidic strength. Is that clear? Okay, student, now after that you must be see second question. Second question is there, we are having, you please see there. Now they are saying there is HClO, then HClO2, then HClO3, then HClO4. Now what they are saying, that HClO4 is having a maximum acidic strength. Now if we will see, we are going to see their oxidation states, then what will happen there? Here Cl is +1, okay, and here in this case in the HClO2 it is +3, yes, +5 and +7. Mean as the oxidation state is increases, their acidic strength is also increases. The reason behind it I will tell you now. You see, when we are removing hydrogen from the HClO, it will form HClO negative, and when we are removing from HClO2, it is forming ClO2 negative, and when we are removing from HClO3, it is forming ClO3 negative, and when we are removing from HClO4, it is forming ClO4 negative. Is that clear? like this way only we are forming. Now what they are saying, after the removal of hydrogen beta, they are saying ClO4 negative is having maximum stability. ClO4 is negative is having maximum stability. Okay, and ClO negative is having a least stability. Okay, now we will find out the reason that why ClO4 negative is maximum stable after removal of hydrogen and ClO negative is least stable. Okay, you just see there all of you. Now we are going to make the structure of all. Okay, suppose first of all I am going to make the structure of ClO negative. Okay, beta, this is the structure of ClO negative. Next one ClO2 negative, then ClO2 negative. Then what will be there? You must see. Okay, then there is okay, this is ClO2 negative. Okay, then after that ClO3 negative. What is it? This is ClO3 negative. Okay, one with the one lone pair. Last one is a ClO4. Okay, you see please, ClO4, this is negative. Okay, but now you see all of you please what I am going to make. See, I am making their resonating structure like this way. Okay, like this. Now you might be surprised ki sir what you are forming over there, but this is a double bond chracter. Double bond can be anywhere. Usually oxygen is making a double bond, so I am making the resonating structure of everyone. There can be a double bond can be here also, double bond can be here also, same way. And just remember all of you, these are that is why I am drawing these as an dotted line. What should be it should be as a dotted line. ठीक है, अब देखो ध्यान से इधर, you must see there, see this is the dotted line. Okay, here also beta you must see there, this is the dotted line. Okay, this is the dotted line. I hope you all are getting my point what I have done there. Now we have to see there why this one is maximum stable ClO4 negative. You can see there ClO4 negative is maximum stable. The reason behind is very simple, is this one only, that here negative charge is delocalized on the 4 oxygen. Now how many oxygen is there beta? On the 4 oxygen, number 1, number 2, number 3 and number 4. Okay, here negative charge is delocalized on the 4 oxygen atom. Is that clear? So that is why its stability will be more. But here only 3 oxygen atom along with that one lone pair, but here only 2 oxygen atom and there is 2 lone pair, and here is only 1 oxygen atom and 1, 2, 3 lone pair. Is that clear? So that is why ClO4 negative is having maximum stabilization. What is it? Maximum stabilization, ClO4 negative, and ClO negative is having a minimum stability. So that is why after removing the H positive, ClO4 negative is maximum stabilized, because here negative charge is coming on all the 4 electronegative element of the oxygen. Is that clear? Okay, okay student. Now see after that beta, third one more question is there, number 3, one more question is there, that is, you see please, now what they told about the perhalates. What is it? About the perhalates, you please see all of you, they are writing BrO4 negative, IO4 negative and ClO4 negative. But you please must write this one in the note, because here they are talking about, in this case they are talking about their oxidizing power. What they are talking about? Their oxidizing power. Oxidizing power means oxidizing strength, means oxidizing agent strength. Okay, it means what they are saying that BrO4 negative is having maximum oxidizing power and ClO4 negative is having a minimum oxidizing power. Okay, now what is the reason behind it? But this reason we can explain on the value of electrode potential value. Which value is there, beta? Electrode potential value. I think you know very well, in the electrode potential there are two type of value. One is reduction potential and one is oxidation potential. And you know very well, if the reduction potential value will be highly positive, then that element or molecule will undergo the reduction. Now you see, all of you please, here I am writing reduction potential value of BrO4 negative is 1.74 volt and IO4 negative is 1.64 volt and ClO4 negative is 1.23 volt. Understood, all of you? Or have you understood, all of you, my point? So that is why beta BrO4 negative is having a maximum oxidizing power. BrO4 negative is having a maximum oxidizing power. Is that clear? Is that clear to you to all? Okay, so these are some queries are there for the oxo acids of halogen. Okay students, thank you very much to all of you.